Hey guys, Remy here. So what is Ethereum? Now, Ethereum is basically a computing platform on which you can run any arbitrary program called smart contract. Now, to better understand Ethereum, let's dive back in history a little bit to the olden days of computing platforms. Now, back in the day, when you wanted to host, say for example, a website or some content on the internet so that other people could access it, you would do so on your own computer. So you would basically have your own computer at home, and let's just draw a computer with that little tiny keyboard as they were, say, back in the 90s or 2000s. And then you would create a website, you'd write some code that you would run on your own computer, and you'd open it up to the internet. So regular users from outside of your computer, say just some people from all over the world, they would be able to access your website by connecting directly to where you are running it. In this case, in your own computer. So they would connect to your computer and they'd be able to see the content that you are hosting for them. And this was one option that you could do it. Another option would be to hire a company that had a server farm. So hire server space from a company that had dedicated servers and host your website on their servers. So let's say this is a server, and you would host your website on their specific servers, and then the people who want to access your website, they'd be able to connect to those servers and access your content there. So just say this is another person over here trying to access your website. Now, this was rather costly. So you had some choices when you wanted to host some content on the web, or on the web, like a website or anything else. You would either host it on your home computer and allow people to access that. The obvious drawbacks of this is that your computer is not that powerful, probably, which means that as enough people try to access your website, it will most likely crash. And another problem with this is obviously the security aspect. If you allow people free access to your computer while given the lack of security protocols, they could probably get up to no good. Now, your other option was to build your own servers. So if you were a company or a small business or even a big business and you wanted to host some content on the internet, you'd build your own servers and you'd host that content on those servers. And the people who wanted to access your content, they would basically access your servers. So this is how Facebook started and Google started. They built their own server farms, and they hosted all of the information related to Facebook on their own servers. So when you or I want to access Facebook or Google, you really are just accessing their servers, which are really not different than your home computer, just way more powerful and with different security protocols and probably specialized operating systems in order to run all of that content. So then some years pass by, and in the mid to late 2000s, there comes the advent of the cloud, mostly pioneered by Apple, as far as I know. So they invented the cloud, and the cloud is basically a server farm. It's literally no different from a simple server farm. So just like these servers here, so we have multiple servers, and the cloud service provider, in this case Apple in our example, what they do is they allow users, regular users like myself, like yourself, like anyone else in the world, to host their own content on the Apple servers for a small or reasonable subscription fee, depending on how much traffic you get. So now I have this option. So let's go ahead and erase all of this stuff. Actually, there's no need to erase. It might take too much time. So basically, let's drop a server over here. So we have a cloud server hosted by, let's use Apple in our example. So it's hosted by Apple. Let's just say this is the Apple logo, right? Looks more like Amazon, but yeah, whatever. And regular everyday users, they can go ahead and they can access this cloud server. And on this cloud server, I, a hoster of a website or content, so I put my website up on the cloud, on the server. I pay them a subscription fee in order to have that server space on which I can host my website. And then users from all around the world can access this cloud server in order to access my content. So this is how cloud computing works. And the main difference between just a server farm like it was before and cloud computing is there's actually not much difference to it. It's just that the cloud servers, they also offer different kind of software and utilities that people who host their content can use. For example, different computational environments, different programming environments, different tools to make everything easier. And the real revolution of the cloud is that basically it allowed for hosting of the content in a good way, in a secure way. It opened that accessibility to the rest of the world, so anyone can host on cloud, paying a reasonable, sometimes small subscription fee for a hobby project. Sometimes it's even free, and they can host anything they like. So these hosting paradigms, these computing platform paradigms, they have something in common, which is a single point of failure. Meaning that if my website is hosted on my own computer and somebody takes out my own computer, so my own computer goes bust, or my server farm that I built for my business goes bust, or the cloud service provider, like the Apple servers, how highly unlikely that is, they just go bust and the server farm explodes. Or say, for example, they just decide to boot your website from their clouding platform. They just stop hosting you because they feel like it, or maybe the government mandates them to stop hosting your content. So as soon as that happens, it's a single point of failure. When they go bust or they stop hosting your content, then your content is gone from the internet and the users can no longer access it. Now, this is where Ethereum comes in, where with the difference. So Ethereum basically, in a sense, is also a hosting platform. It's a computing platform where you can host and run your programs, your content. However, with the Ethereum ecosystem, there's a thing called nodes, and you run the nodes on your computer. I run a node on my computer. There's a whole, like 1,000 more people run nodes on their own computers. And each of these nodes is your little computing platform that runs your program. So they're all interconnected. I'll just make a connection so that it's clear. So all of these nodes are interconnected with each other, and the conjunction of all of these nodes is called the Ethereum network. And all of these nodes are hosting your content on them. So each node has your content. So if I wanted to host content and run a program on the Ethereum network, I'll upload it onto the network, and each of these nodes will have my content. So if one of these nodes goes bust, if my computer that's running the node explodes, you can still access your content through any of the other nodes that are available on the network. And the more people that run this, the harder it becomes to remove your website from the blockchain. So the government can just mandate for people to block your website, because then, well, you can't just control all the nodes. So this paradigm means that it's running in a decentralized manner, where there is no single point of failure involved. As I said, one node goes out, your program is still intact and running on the Ethereum. Now, there is a small problem that presents itself when you have this kind of an ecosystem. That is, for example, when a user, suppose this is the user, right? And the user wants to connect to your website. So the user wants to connect to your content, to your program, and your program is hosted on the Ethereum network. So it connects to the Ethereum network, and it basically queries your content. So suppose this node right here is hosted by Charlie, and Charlie thinks to himself that hey, maybe I'll just I see that this website is hosted by this guy called say Remy. I'm hosting the website, and Charlie says, I'm just going to deface this website and change its contents completely and serve my version of this website to this user call. Let's call this user Jake. So I'll serve my version of the website to Jake, and Jake will be none the wiser, and he'll just see my version and he'll think that's the authentic version. So as you can immediately see, this is not very secure. So the way we solve this problem is by having a massive data structure on which all of the content of the Ethereum network is hosted, called the blockchain. So the Remy's website, when he uploaded it onto the Ethereum network, is hosted, is stored in a data structure called the blockchain, and everyone else's content as well is stored on that blockchain, which is run by all of the nodes in the network. So how a blockchain comes to a general consensus of which content is right and authentic and which is not, is as follows. So we the way we do this is through an algorithm, and Ethereum kind of runs a proof of work. So basically a blockchain is a bit like a linked list. Instead, like, so we have all of the data, and they're divided into segments we call blocks, and each block has some data in it. So it'd be like and this data is called the state of the network, and each of the subsequent blocks represents added data to the network or a change in the data of the network, so a change of the state of the network. Now, in order to for Charlie to be able to manipulate, to be able to change the website that Remy originally uploaded onto the Ethereum network, it will be to he'll need to add a block to the blockchain. So he'll need to be able to change the contents of the website. So for example, this is the original website. This block represents the original website that Remy uploaded, and all of the nodes agree that this is indeed the original block. So when Charlie wants to change the contents of the website, he'll have to add a block changing the state of the Ethereum network, that is thereby changing the contents of Remy's website. So this is Charlie's block. Now the only way to add a block to the blockchain will be to do something called validate the block. And the way the blocks are validated in the current consensus called proof of work is as follows. So Charlie will have to take this entire block and then take a random number that Charlie will have to calculate, such that this block plus the number that Charlie calculates hashed is equal to a certain hash where, for example, there are 10 preceding zeros. So I'm going to write it down to make it more clear for you. So I'm going to represent the block as B. So B is the block. This is known information plus the random number, and let's call this random number X. Now X is an unknown at this moment, so we don't know what X is. Charlie will have to calculate it. So the equation here is this. So we take the block, all of the data in the block, plus whatever number that Charlie will have to find, such that when all of this is hashed. So hash is an algorithm that basically does something to the number to produce a string of digits and characters. So when this block is plus the number is hashed, the resulting hash has, suppose, 10 preceding zeros plus some characters, but the only definition of it is that it needs to have 10 preceding zeros in order to be valid. So once Charlie obtains the X, and this is the key here, the only way to obtain this X is to try every single number one by one until you actually get the right number that results in this particular hash. So for example, you'll need to try number 1, so you take all of that in this block plus 1, and then hash it up, and you'll see if the resulting hash has 10 preceding zeros. If it doesn't, then you'll take number 2, you'll do the same, then you'll take number 3, and so on and so forth until you go all the way to whatever number you need in order to get the valid hash. It can be a very large number, it can be a very small number, it just depends. But overall, so once you have the number X, you need to sign this block with the number X, and once that block is signed with a particular number, then and only then can you actually chain it up to the rest of the blockchain, meaning that you make a valid addition or a change to the blockchain, which Jake can then see. Otherwise, if this block is not signed by the X, it is discarded by the system and not accepted. So if Charlie changed the contents of Remy's website and is sneakily added the block, if it's not signed by the X, the Ethereum network is not going to accept that block, which means that it's never going to be served up to Jake, and Jake is not going to see the malicious content. However, Charlie can indeed go ahead and verify this block, validate this block by basically, and by the way, the validation of these blocks by looking for the right number, which will then equate to the desirable hash, is called mining. So Charlie can mine the block, so he can change the block to serve his own purposes, and then he can mine it himself. And once he's mined the block, he can add it to the chain, sure. But all of the nodes in the network simultaneously will do the same thing. So once Charlie announces the change to the network and he's gonna mine the block, all of the other All of the other nodes, they don't have Charlie's change. They only have the original website that is hosted, that was initially uploaded by Remy. So as they validate their own blocks, they're gonna have a different block, because as you can see here, if this block, if the data of this block is changed even a little bit, then this number will no longer be a valid number in order to equate to a desirable hash. And that means that once the block is signed by this number, it can no longer be changed. In order to change this block, you'll have to basically do the whole work again, looking for the new X in order to be able to sign it with a new number. And this is called proof of work. So you'll have to do the whole work again in order to be able to change the block. So as Charlie appends the Charlie's gonna try to mine and validate his malicious block, while everyone else in the network, assuming that they're honest nodes, they're just validating the blocks that are the block with the data that is the original website hosted by Remy, which means that they're gonna have the rest of the network. So this is Charlie's block, and the rest of the network is gonna have a different block. So this is a different block signed by a different key that represents the original data. So in this case, if Charlie mines one block, and he can indeed mine it before the rest of the network, Charlie has a lot less computing power than the rest of the network combined. So assuming that holds true, and the rest of the rest of the network, so the honest part of the network holds more computing power than the dishonest part of the network, in this case all of the network versus Charlie, then over a longer period of time, the honest part of the network is going to be able to validate and add blocks to the blockchain faster than the dishonest part of the network, in this case Charlie. But Charlie can indeed validate a block before everyone else. Probabilistically speaking, it is unlikely, but it's definitely possible. So suppose that Charlie validates a block that is malicious, and it adds it to the network, while it adds it to the network, and the rest of the network adds another block that is the truth. So now the blockchain splits, and it has different blocks that don't agree with each other. So one chain goes this way, the other chain goes that way. So this is Charlie's chain, and this is the honest chain. So in this case, the rest of the network keeps on validating and adding further blocks. So it's going to add another block, and it's going to add another block. And Charlie has to keep his chain alive, so he's going to try to add another block, and he's going to try to add another block. But the thing is, since the rest of the network holds more computing power combined than Charlie by himself, the honest side of the network is going to grow faster than the dishonest side of the network. And another consensus of the blockchain is that the Ethereum network is always going to follow the longest chain. It means that the one that has more blocks is going to be the one that's going to be served to the end user, in this case Jake. So Charlie cannot keep up with the rest of the network by adding blocks faster than them, which means that his chain that contains malicious and dishonest information is eventually going to be discarded in favor of the honest chain. And this is where blockchain gets its security from, meaning that once you put something up on the blockchain, it is practically immutable, meaning that once it's been validated, it's immutable. It's just gonna stay there, and no malicious actor can change that information. Now let's move on to the next concept. So so this is all good. This is all good and peachy for now, but the question arises: why would the nodes be motivated to actually do this work? So why would I run an Ethereum node on my computer, or why would you, or why would anyone else run their computer and exert their computing power in order to validate these blocks and changes to these blocks that we're going to call transactions from now on? So each change to a block is called a transaction. So why would I do this? So all of the nodes that are mining the Ethereum, besides altruistic reasons of actually helping the network, they're financially incentivized to be able to validate these blocks and run the network. And the way that works is each time a node validates a block. So for example, this node, this is an honest node, and it's gonna validate the block, and it's gonna add it to the blockchain. And each time it adds a block to the blockchain, it's gonna get rewarded by a newly minted ether. Suppose this block just validated the this block has this node has just validated a block, and it gets rewarded by 2 ether, for example. So it gets itself 2 ether. Ether is the cryptocurrency that runs on the Ethereum blockchain. So each time, so let me just reiterate this to make it very clear. So each time a node successfully validates a block and adds it to the blockchain, it gets rewarded by ether, which means that all of the nodes are financially incentivized to mine, to validate the blocks on the network. And the more nodes that join the network, the less likely will a malicious actor such as Charlie be able to actually modify the network to his own nefarious purposes. So what is Ether? Now, let's look at it this way. So we have the Ethereum network, and all of the data in this Ethereum network is stored on the blockchain, as we've discussed before. Now, part of this data is actually different addresses. So for example, my address of my Ethereum wallet is something 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 with characters, and this particular address has a particular balance of, say for example, 7 ether. So my wallet has the balance of 7 ether, and somebody else's wallet, so for example, this is Remy's wallet, and for the example's sake, let's say Charlie's wallet has a balance of, like, this is Charlie's wallet, and it has a balance of 2 ether. Now this data here is stored on the blockchain in the blocks, which means that Charlie can go ahead and modify his own balance to increase it by something he doesn't have because of the proof of work, as we've discussed before. So when Charlie wants to transact this if Charlie wants to pay me 5 Bitcoin and 5 Ethereum and he doesn't have it, then the all of the validators are just gonna check against the data. So you can basically check on the blockchain, does Charlie have 5 Ethereum, 5 Ether? No, he does not. So the transaction is going to be declined. Whereas if Charlie wants to pay me 2 Ether, it's going to check, does Charlie have 2 Ether to pay me? Yes, indeed, he does. So the balance is going to be subtracted from Charlie's wallet and it's going to be turned to 0. And Remy's wallet is going to be turned to 9 since Charlie just paid me 2 Ether. And since this transaction is actually valid because there, you can check it against the data on the blockchain to see whether this is possible to exact. And once that is verified, another block will be added to the blockchain by all of the validators or miners in this case. So they'll basically create a block using proof of work, as we discussed before, finding the right number, hashing it, and seeing that has a certain number of preceding zeros. And once it does, they're going to sign the block with that number and they're going to add it to the blockchain. So this is going to be the new valid state of the network. That is so this is the Ether, and that's how it basically works, is that it's simply data on the blockchain, and people can then use that data in order to see how much balance each account on the network has, in order to be able to see if a transaction is a valid transaction or if it's an invalid transaction. All right, so everything we've discussed so far, this entire system is almost identical to another famous blockchain, that is the Bitcoin network. So what exactly is the difference between Bitcoin and Ethereum? So between the Ethereum network and the Bitcoin network. Now, to understand that, we'll need to understand a concept called Turing completeness. So there was this guy, and his name was Alan Turing. He's widely considered to be the father of computer science and modern computing. And he invented this concept called the Turing machine. And the easiest way to think about the Turing machine is basically a computer that can calculate a certain value, or in other words, in modern terms, basically a computer that can run a computer program. So in order to be Turing complete, a Turing machine has to be able to run any computer program of any arbitrary complexity, which my computer that I'm doing this tutorial on, or your computer at home, can probably do. So most machines or computers are indeed Turing complete, which means they can run any program of any arbitrary complexity. So the on a Turing complete machine, you can now, for example, run a computer that supports if statements, and you can run a program that supports if statements, and you can run a program that supports the loops, and you can run anything else. So the Bitcoin network is not Turing complete, which means that you cannot run any program of any arbitrary complexity on the Bitcoin network. The only thing you can run on the Bitcoin network is a simple script which can check whether or not a certain wallet, as we've discussed before, has enough balance in order to be able to execute a transaction. If it has enough balance, so you can do if statements. So if that wallet has enough balance, it gives either a value of either true or false. That is Boolean. So if it has enough balance, it goes to true and transaction is executed. Otherwise, it results in a false and the transaction is not executed. Now that is by design. It's a very good feature in the Bitcoin network, meaning that no program of arbitrary complexity can be executed. And let me explain why this is by design. Suppose that the Bitcoin network was indeed Turing complete. That means that somebody, not looking at you, Charlie, but some guy named Charlie could just create a program that will get stuck in an infinite loop. So basically, Charlie creates a program that gets stuck in an infinite loop and just continues on running forever without ever stopping. Now he's gonna upload this program onto the Bitcoin network, and all of the nodes inside of the network are just gonna keep on executing this program over and over and over again because it never terminates. And this means that it's basically clogging up the network, and it's clogging up all of the computing power of everyone else collectively running the nodes. So effectively speaking, while Charlie's program is running, nothing else can happen because you have to finish Charlie's program first. And the more programs the people like Charlie upload to the network, the more it's gonna get clogged, the more nodes are gonna get clogged, and this is effectively a DDoS attack against the blockchain. And the only way you can actually reset this and stop Charlie's program will be to shut down every single node simultaneously and then power them back up, and while also resetting the blockchain, meaning that I'm agreeing with every single node that you don't need to actually run Charlie's program. Charlie's program is not valid, we need to stop it. And in the case of a blockchain, as you can probably imagine, that is next to impossible, practically impossible to get all of the nodes to shut down at the same time because they're run in a decentralized manner. Meaning that if I'm running my computer, I'm running another my computer, and you're running your node on your computer, you can't just we can't just coordinate the shutdown at the same time, and then somebody else running their own node in North America and somebody else running their node in Europe, and basically, yeah, I'm just rambling at this point, but you get the idea. You cannot reset the blockchain. So once Charlie uploads such a program on the Bitcoin network, the blockchain of that network, the whole network is kaput because it's basically just going to be too congested to be able to do anything else. So what Bitcoin does is Bitcoin does not allow for programs to execute loops on its network. So its scripting language is not Turing complete, meaning that it cannot run Charlie's program. Charlie's program is not executed on the Bitcoin network, and the Bitcoin network is then safe and secure, and it continues to power along and process transactions. It's never going to get clogged. Now, the Ethereum network, on the other hand, is Turing complete, which means that this guy named Charlie can indeed upload his malicious program to the Ethereum network, and it can execute this loop, and it can just run and run and run this loop and clog the Ethereum network by just never finishing, because Ethereum network can run loops or any other program of any other arbitrary complexity. So how does Ethereum combat this particular situation? How do we solve this problem with Ethereum? Well, we solve this problem with something called the gas fee. Basically, each time Charlie wants to execute his program on the Ethereum network, he has to send this program onto the network along with a certain amount of ether called the gas in order to be able to pay for the gas fee. So suppose he sends this program along with one ether. It'd be wildly expensive, but just for our example's sake, let's say Charlie sends this program onto the Ethereum network along with 1 Ether. Now, the program is then broken down into each computational step on the Ethereum network. And each computational step costs a certain amount of gas. So for example, each time it executes the loop, and remember this program is running in an infinite loop and it's never going to stop. So each time the network executes the loop one time, it's going to subtract, suppose the gas, it's going to subtract, suppose 0.1 Ethereum. So each time it's going to execute this loop again, it's going to subtract another 0.1 Ethereum, and so on and so on and so forth. And as soon as this Ethereum dries up and is no longer able to pay for the gas, then the program will stop executing. So if Charlie only sends 1 Ether with this program that is going to execute the infinite loop, it's only going to be able to be executed 10 times, assuming that the gas fee per execution is going to be charged at 0.1 Ether. Meaning that as soon as the Ether dries up and the gas fee is no longer able to be met, then the program will stop executing. So because Ethereum solves this problem by introducing the gas fee, it means it is able to be Turing complete in a secure manner. And the implications of these are that you can run any program of any arbitrary complexity on the Ethereum network as you would on a typical cloud server. This means that you can run your applications, you can run your website, you can run any content you like. And instead of hosting it on a cloud server, which has a single point of failure, as we've discussed before, you can host it on the Ethereum network. And the implications of this is that your program is now run in a decentralized manner, and it is censorship resistant because it does not have a single point of failure. And likewise, it is very secure because it runs on a blockchain that has rigorous validation protocols, as we've discussed before. And yes, so this is basically the advent of Web 3.0, where when users want to connect to content hosted online, instead of having all of our web content and all of our data and all of our programs run on server farms, such as the Google Cloud or the AWS or iCloud or Microsoft Azure. So basically all of our data is currently being hosted and run on these massive cloud servers that are stored in one particular place, maybe even distributed all over the world, but they still belong to one or a few single entities, in this case Google or Microsoft, and they're still stored in one single place. So there's still a single point of failure, because if these cloud hosting providers implode, however unlikely that may be, or if they decide to basically stop hosting your content, don't ban it, well, that's it. Your content is now gone from the internet. So you don't own your content. It is owned by them. You just host, they're hosting it for you. Whereas if you host your content on the Ethereum network, it is decentralized, meaning that it does not have a single point of failure. And if one node is taken out, your content is still being hosted by the multitudes of other nodes hosted by people all over the world, meaning that it is censorship resistant and it is secure by default, which means that nobody can tamper with your content. In theory, if you host something on the cloud, suppose you host something on the Google Cloud, of course they wouldn't do this, but in theory, Google can go ahead and change the contents of your website and serve it up to people, and they'll think it's the authentic website that you posted, whereas it's actually been modified, and nobody would be the wiser. Whereas with the blockchain, as we've discussed before, through the validation methods, it is virtually impossible to modify the content once it's been uploaded to the blockchain. So this is the advent of the new era that we are seeing past the cloud era, which is the decentralized hosting era, otherwise known as Web 3.0, where we can have decentralized applications hosted on blockchains such as the Ethereum network or any other ones that support this infrastructure. Alright guys, thanks for watching. I hope you liked this video. This was just a simple high-level overview of what Ethereum is. In the future, I plan to make more videos that dig down further into the technical details of how to actually make smart contracts, the Solidity programming language, the wallets, how the wallets work, and the different consensus algorithms such as proof of work and proof of stake. and difference between the two, how they work, and so on. Now, if you were inspired by this video and you want to learn more, in the meantime, I highly recommend you to read this book called Mastering Ethereum. It is free and it is hosted online on GitHub. And of course, I'll leave the link down in the description. Check it out. It's a brilliant book. I've been reading it. I cannot recommend it more. And if you like this video, of course, hit the like button. That really helps me out and lets me know that you like this kind of content and you want me to do more of it. And please leave a comment. I'd love to have a discussion with you. Ask me any questions you feel like asking. I'll generally respond within a day. And as always, thanks for watching, and I will see you in the next one.